Yeah, I apologize for this. I start sharing again. Yes, so this is the second version of Auto Diaphragm version 2. I assume that most of you are not also familiar with the first version of the program. Therefore, I just start from scratch. So there are icons here, and if you stop your mouse on the icons, there will be explanation about what each icon is. To start a model, I simply click on Open ETABS model. It will open an existing ETABS model, and then from there you can use the software to generate the Stratantine grillage. I clicked on the open model in my other screen. It was trying to open ETABS. And for this presentation, I just use an existing ETABS model. I push the open button, and it will go and open ETABS, that specific file for me. It is being opened in my other screen that you cannot see, but I just bring it to this screen. So the ETABS model has now been opened through Auto-Diaphragm program. So there is a connection between ETABS and Auto-Diaphragm at this point. And you can see that number of story levels in that model has been now uploaded here. And you can see the number of floors in here. If I go to the original model in ETABS, I can see, I just briefly show you, this is just an example building that I've chosen for this presentation. It's a 3-story building with shear walls in both horizontal directions. If I want to see the diaphragm's definition, the user has defined diaphragm for the floors. If I right-click on it, I can see that there is diaphragm D1 assigned to each floor on all levels. And if I go to the define menu and diaphragm definition, I can see here that this diaphragm has been defined as a rigid diaphragm by the user. So the building has a rigid diaphragm in all different floor levels. Now our purpose is to undertake Stratantine analysis of floor diaphragms for this building. One thing to note is that as soon as I open an ETABS model through Auto-Diaphragm, no matter what the name of the model has been, the name will automatically be changed to a temp model, and it is saved in one of the hidden directories of Windows. Therefore, it's very hard to find this temp model file because it's in one of the hidden folders of Windows. So the first step is to go and save this model with a new name at a new location that you want your model to be saved. For example, I can just go here to my desktop. I create a new folder and I just call it test and save this model as a test model. So this is the first step that I would recommend every one of you to do when using Auto-Diaphragm. This protects your original ETABS model. So every changes that you make here with Auto-Diaphragm is not going to affect your original model. So if you look at these toolbars in Auto-Diaphragm, they actually tell you what steps you need to take in order to generate grillage in Auto-Diaphragm. There are several options in using Auto-Diaphragm, specifically in version 2. So you can generate the grillage only for one specific floor level, or you can generate grillage for all floor levels at the same time. In this particular example, it's up to the engineer, first of all, to decide whether you want to generate grillage at the same time at all floor levels, or you want to generate grillage at a single floor level at a time. There are different pros and cons between these approaches. I'm not going to go into details of those approaches, but what I can tell you is that you've got the option and ability in AutoDiaphragm to either generate the grillage for a specific floor level or all floor levels at the same time. In this presentation, I'm just going to, as an example, generate the grillage for level 1. So what I'll do here is that I come and uncheck level 3 and level 2 in these options in here. So that means that no grillage will be generated on levels 3 and 2. But one thing to note is that all other options, all other parameters that you see here, they are still active, even though that this has been unchecked. I'll go through these options and these parameters and explain what they mean and how you need to actually use them. So now our purpose is just to generate the grillage model for level 1. And the next step is to select some base points. Base point or selection of base point is an important step in generating the grillage model using AutoDiaphragm. Using the base point, the program will understand in reality where your supports, I mean the vertical supports are. For example, if you have a wall here, you have a wall here, and you have a wall here, these are the supports for your diaphragm actions. And one way for the program to understand your supports is through base points. How the base points work, I will explain in more detail. You need to select at least 4 base points at the floor level that you would like to undertake a strata and tie analysis or generate a strata and tie grillage. So for this example, I just first select 4 points. Typically, these 4 points that are the minimum required should be the 4 corners of your building. And then I explain to you how it works. So by selecting each point, then what the program does is that draws a line in the horizontal X direction and horizontal global Y direction. And then from this line, so it draws a line here, it draws a line here. At this point, it draws a line here, it draws another line here. And once all these lines are drawn, then it starts to divide the spacing between these lines with the maximum spacing as you specify here. If I just scroll to the right, you can see there is maximum mesh size option here. So now that I've selected this joint and this joint here as an example, what the program does is that it draws a line here, a grid here, and it draws another grid here, and then divides the spacing between them with the maximum of here, 1,000 millimeter or a meter. As I run the analysis and the grillage model, you'll see it better, and you'll probably understand better what I mean by that. So I stop here for the base points, pause it in fact, and I come back to the base points. Now my base points have been selected. There are other options. There is one important decision that you need to make at this point, and that is, what happens is that now that I have decided in this particular example to generate the grillage model only for level 1 and leave the other levels as they were originally, I need to make sure that the stiffness of my model that I'm using for diaphragm analysis is close to the stiffness of the model which I have used to design the structural components. In other words, if I had, say, as an example, 1,000 kilonewton shear in this wall in my original model, I would like to have a close value here. If this has been originally defined as a rigid diaphragm. If I now change it to a strata and tie grillage, so obviously this won't be a rigid diaphragm anymore. Therefore, the stiffness of the floor is different. Therefore, the distribution of the forces between the walls will vary. So this is very important to make sure that you are consistent in your design, in your original design, and also the model that you use for diaphragm analysis and design. In this example, the user has defined a rigid diaphragm. So somehow I would like to replicate also a rigid diaphragm here in my analysis. These options that you see here, this is floor stiffness modifiers which will be assigned to floors. This is a strut and tie stiffness modifier, axial component. These are the strut and tie, the axial strut and tie stiffness, the stiffness modifiers to the axial component of the strut and tie elements. And this is a stiffness modifier to bending component of the strut and tie elements. So one thing to note is that as soon as you start generating a grillage in auto diaphragm in a particular flow level, no matter what you have defined for the diaphragm in the original model, auto diaphragm automatically goes and changes the model to changes the diaphragm to a semi-rigid diaphragm. That is because it assumes that it is generating a grillage model which is no longer completely stiff, and it's a semi-rigid diaphragm. Therefore, if I want to retain still the rigidity of the floor 3 and 2, then I simply go and give a large stiffness modifier. In this example, I just choose 1,000 to the stiffness modifier of the floors for level 3 and 2, because I'm not generating a grillage model in level 3 and 2, and therefore I just want to retain them as rigid diaphragms. This option for level 3 and 2 doesn't matter because I don't have any strut and tie components, so this number does not matter. So for level 1, because I will be generating grillage, therefore I don't want my floor to have any stiffness, because if my floor does have any stiffness, then the loads will go to the floor and won't go to the strut and tie components. You might be confused at this stage, but I promise as I go further into the example, you will understand it more. Now, but in order to somehow replicate still a rigid diaphragm, even at flow 1, so that the loads between the walls are distributed close to a rigid diaphragm, again, one option here would be to give large stiffness modifier, this time not to the floor, but to the strut and tie components. I just give it stiffness modifier of 1,000 here in this example. It is advisable to leave this bending component of the strut and bending component stiffness modifier for strut and tie components a very small value, because we don't want our strut and tie components to attract any bendings. They are simply tension and compression elements. I spoke about this maximum mesh size, but you will see it through an example better now. So once we know what we are doing with these parameters and we have made decisions about what we are going to do with these parameters, we have selected these points, the base points, as minimum, as I said, 4 base points. Typically, you must have base points at the locations that you've got a vertical support, which are in this example the shear walls. The next step would be to go to this icon, and that is the set base points. This is a very important step. So as soon as I click on set base points, these base points are saved in the program, and also an automatic group is defined here. If I now go to the select and select group, you can see that here these groups have been defined, so that if I unselect or go clear selections on level 1, and if I select this one and select it, it will show me what points have been actually defined. Now, the next step is very simple. I can simply go and push this button, which is generate geometry, and it will automatically generate the strata and grillage for me. You can see how it is going here. Depending on how big your model is, it might take some time, but generally it's very fast. If I go here, you see an overview of the grillage generated for this building here. And if my mouse was on level 3, this would have been empty because no grillage has been generated for level 3. No grillage has been generated for level 2, but level 1, the grillage has been generated. If I go back to the ETABS model, I can see here that the grillage has been generated for level 1, 2, and 3. I stress here at this point that it is important for the design engineer to make sure that they are happy with the way that loads are distributed between the walls in this model in comparison to the original model. So from here, some engineers may decide that, okay, they just want to remove the other levels and then apply the loads manually to make sure that all the loads match with the original model. Or some engineers decide to go with a 3D model, as I'm doing it in this example. What I have personally seen is that most of the time with the 3D model, you are able to play with these parameters that I showed you here to get a consistency between both models. Now that this has been generated, I go a bit into more details of how the program has generated this grillage. As I explained, so the program has, based on the basement, has drawn a vertical and a horizontal line. And then between these lines, it has drawn other lines so that the maximum mesh spacing is as specified here. Once it reaches to an opening, it can recognize openings, and it has stopped. So it recognizes opening and it won't draw. I have deliberately drawn this strange shape here so that you can see how the software treats it. It tries to get as close as possible to the edge, but always it doesn't get completely to the edge. Again, it's based on the engineer's judgment to see if this is acceptable or not. If it is not acceptable to you, there are ways to improve your model. One way, for example, is that if you really want to get this closer, you can also define a base point, say at this point, at this particular point, and rerun the model. For this example, just to show you how the definition of base points can help you to better generate your grillage, this time I select also this point as a base point and rerun the model. The good thing about the diaphragm is that it's very easy. You can run grillage in blink of an eye. So you can try different options. It's very easy to do try and error, and it doesn't take a lot of time. So your hands are really open to several options. To reset the base points, this time I go to the select and I go to the groups, and I select this story one base points. By pushing this select button, my previous base points are shown. I go this time and also select this point. I go back to auto diaphragm. There is an icon here, delete geometry. I click delete geometry because I want to change the geometry in this case. I click on delete geometry. It is deleting. It's been deleted in a blink of an eye. You can see that it's been deleted here. If I go back to the ETABS and refresh, you can see that it has also been deleted in ETABS. This time, just to show you the effect of maximum mesh size, I also decrease the mesh sizing. I don't decrease it much because it might take more time for generating the grillage, but I just put 800 as an example. And then again, when I do have these points here, I go set base points. It shows me here how many base points I've had on this level. And now I go to the generate geometry again. I click on the generate geometry. It shows that it's generating a stratified geometry. It's a lot of analysis going on at the moment behind the scenes for you to see that grillage. One of the points that the program has to do is to calculate the cross section of the strata and tie components, how the strata and tie component sections are defined. I explain in more detail now. As you can see on level 3, there is nothing. On level 2, there is nothing. On level 5, if I go, I can see an overview of the grillage generated. So this time, if you could recall from last time, this point has been included. That means that a horizontal line and a vertical line has also been drawn here. And now we've got also this point. If I want to take this opening again, even better, I can select more base points, say this one and this one. And this time, again, I go back to auto diaphragm, go delete geometry. I'm just doing that so that you guys can see the differences and can see the role of selection of the base points in generating your strata and tie grillage. I go select base points. This time I've got 7 base points. Generate the geometry again. My maximum mesh sizing still was 800, and I just want to see what difference it makes. I was talking about the cross section of the strata and tie components. The cross section of the strata and tie components in auto diaphragm is defined based on the grid spacing, and then is multiplied by these values that you can change in here. For instance, in this particular example, when the grid spacing has been 800 millimeters, the width of these sections is maximum 800 multiplied by this effective width, which this is used for orthogonal components and this is used for diagonal components. The default values are the values given in C5, but you've got the option to change them. Doesn't mean that all the section width are 800 necessarily, because it just divides the spacing between these two equally, and so that it's not more than 800. So most probably the spacing between the grids are actually less than 800. If I want to see the section which has been defined for each grillage, I can simply go here and go to the frame section. This shows the section sizes. If I go also to the define menu and I go frame sections, you can see here that behind the scenes, this F, the sections starting with name F, are the sections, so many different sections which the program has automatically defined. If I click on any of them and go to the modify show properties, I can see the properties of the section. The depth of it is 100. The width of it is this much, and I explain how that width has been calculated. That width, the width of these components, say for example this one, the name of it also shows the width of it as 600 by 175, meaning that the thickness of the section is 175, but the width of it is 600. That 600 is the spacing between the grids multiplied by this 0.75, which has been specified here. One point that I wanted to make here, I hope that you could at least get some idea about how the software works. You can see how easy it is. You can see how you can do several iterations. You can see you've got options to generate grillage in a 2D model, in a 3D model, for one single level, for several levels simultaneously. So there's so many different options that you've got, and as an engineer, you've got to make decisions about them. One thing which is worth to mention here is that once you generate the grillage, another thing that the software does is that it also goes and measures the angle of your struts or diagonal components. And if the angle is less than 25 degrees or more than 75 degrees, it will give you a warning. So that means that probably your grillage generation is not very perfect, and it tells you that, all right, be careful about those components, and if you can, if you've got that option, go and change them. Hello. Yeah, I think my voice was lost for a second, but I'm back again. I was talking about how if the grillage is not perfect, the software gives you a warning. To show you that, again, I go and delete the geometry that I have generated here. If I go refresh button, I can see that everything has been deleted from the ETABS model. This time, I have deliberately drawn a column which is a bit offset from this grid. So I've got a joint here, and if I go also select this joint, these two joints very close by, you can see that there will be a line drawn here, and there will be another line drawn here. Just to show you an example, this time I generate the grillage with these points. And obviously, if these 2 points are very close horizontally, that means that we will have components that are not very great in terms of generation of the grillage. And we'll see how that is treated in AutoDiaphragm. I go, and again, this time go set base point. As soon as I set the base point, you can see that it tells me this time I've got 8 base points. I go and click on the generate geometry. Before clicking on the generate geometry, another point that I was going to tell is that the software understands the thickness of the strut and tie components based on the thickness that you have defined for the floors. If I, for example, go here, the floor which is defined here is S175, and if I go to the define menu to the slab sections, I can see if I go to the S175 properties, I can see that the thickness has been defined to be 175. There are circumstances that you want to change that, or you want to use different thickness in different horizontal directions. You've got that option. You simply go to the notes. There is like this property notes here. So you can go to the property notes here. This is the way that you define the thickness manually for the strut and tie components. The first value that you enter is the thickness of the orthogonal components, or whatever is on your floor in the global X direction. The second number is for the global Y direction, and the third number is for diagonal components. For example, this is just an example. I'm not doing it based on any theoretical background or basis. Just to show you, I want to specify the thickness of the components along X direction 100, along Y direction 150, and for my diagonal components 120. So these 3 numbers I write down in the property notes. I go OK, 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 and then go back to AutoDiaphragm. Set the base points again. Still, I've got 8 base points here. Go generate geometry, and wait until the geometry has been drawn. As soon as it is drawn, this circle stops, and I can also see an overview of the the geometry here. You can see that this time it's taking a bit longer. The reason is that we've got these points, these 2 points close. That means that we're going to have a lot of components which are not really good Stratton type components. I go click on story 1, and as soon as I click on story 1, you can see that a warning pops up, and it tells me that 41 strat elements have unacceptable angle. Unacceptable angle in this particular case means that the angle is less than 25 degrees. If I zoom to it here, I can see this in orange color. It's in fact red color, and I can see that these are the ones that undesirable with undesirable angle that has been caused by me having 2 points which are very close to each other. To rectify the issue, it's very simple. Again, I go delete geometry, and simply I wait until the geometry has been deleted. It's deleted. I can simply just remove this base point here, and I come back and set the base points. This time again, I've got 7 base points, generate geometry, and I wait for the geometry to be updated. This time I'm just going to also show the effect of these parameters on the model, and then we go to the next step, which is loading the Stratton tie grillage model. So this time I don't see the warning because of my base points. The warning has been removed. Just to show you how the thickness of the components this time have changed, I go, if I right click on a particular component, first of all, I right click on the floor. Again, you can see that the floor assigned to this, it's S175. So for the Stratton tie components on this floor, I expect to see those values that are entered in the X, Y direction to the thickness of my Stratton tie components or orthogonal and diagonal components. If I right click on a orthogonal or orthogonal direction, orthogonal element in the X direction, I can see that the thickness has been this time assigned to be 100, and that is the value that I entered there. The width of it has been specified based on the grid spacing, as I explained, multiplied by that modifier that is given here. If I go to the property modifiers, you can see that these number, this 1000 that I had entered for the axial component of the Stratton tie has been assigned to it. So that means that this is an extremely stiff component in terms of the axial loads. And there is also a very small value for the bending stiffness modifier. These are the values which have been defined here for bending of the Stratton tie components. So that means that this component is not going to attract a lot of bending moment, and it is very stiff. The reason that I defined it very stiff was that because I somehow wanted to replicate it as a still rigid diaphragm. It won't be rigid, but hopefully it will be close to a rigid diaphragm. If I right click on the floor again, I go to the stiffness modifier assigned to the floor, and I can see that that's a very, very small value. This value has been assigned based on the value that I've entered here for the third level. If I go now to see the second and for the first level, the small value is for the first level. If I now go to the second level, and which we don't have a Stratton tie grillage model, and I go to the property modifiers, I can see that this 1000, which I have given here, has been assigned to the model. And so has happened to the level 3. Now, I've got my grillage model for level 1. I have assigned the thickness of the Stratton tie components as desired. Assume that I'm happy with my my grillage here, and I'm happy with the base points that were defined. One more point that I want to add is that, so what happens to these components that are on the edge? The software automatically, this is what the new feature that in fact we have entered in revision 2 or version 2 of the software. The software automatically recognizes the openings. Therefore, if I check the width of this components on the edge, you can see that it's 300, and this is half of the width of the component next to it, which if I go here, you can see it's 600. So it is recognizing that on the other side of it is empty. You might want to ask that, so therefore, why is that this component has been drawn here? So the reason is that the way that program recognizes whether it has to draw a line or not is based on these 2 points. If both points, which have been drawn, both points fall inside a shell, then that component will be drawn. Whether you are happy to for this component to be here or not, that's an option that you've got. If you're not happy, you can simply, for example, for instance, for this particular example, just to show you that this is just an ETABS model, you've got all the options that you've got in ETABS also here. I simply go and delete these 2 components if I'm not happy with it. I can even delete this one if I'm not happy with it. But the algorithm of the software is that if you've got 2 points that fall inside shell element, then that component will be drawn. I can delete these components if I don't want them. You can change the section of these components. You can delete any component if desired. You can change the stiffness modifiers. You've got all the options of ETABS. So you've got ETABS plus another software into it to help you model whatever you want for your strut and tie analysis of the flow diaphragm. The next step is loading. So we have generated I explained generation of the geometry. I explained what the base points are. And now we go to the next step, which is applied seismic loading. So in AutoDiaphragm, using this option, you can apply seismic loading to different flow levels. If you don't have a grillage model in a flow level, the loads will simply will be applied to the to joints, whatever joints you've got in the model. And where you've got the grillage model, the joints will apply to these grillage joints. The total force, the story force, you just enter it here manually. You can calculate the total force that is used for your diaphragm analysis using, for instance, the PISA method in 1170.5, and then you just come and enter it here. That load will be automatically distributed by AutoDiaphragm between the joints based on their tributary mass. Note that it's tributary mass, not tributary area. So it is more accurate, in fact. So if you've got different loading on different floors, then that is taken into account. So those floors with more mass, or those joints with more mass or attributed mass to them, they will get more load. As an example, this is again just an example. There's no theoretical basis or calculations behind it. I just put 1,000 kilonewton load for the X and for the Y directions at all flow levels. And I just want to run the analysis for you to see how this load has been or will be distributed between the joints. There are options here to take into account accidental eccentricity and combination of the 100% and 30% of loads in 2 directions. I avoid them for now, but if you tick them, that means that more load cases will be generated for you. I go OK here, and then from here, I simply go apply seismic load. I push this apply seismic load, and what happens is that as soon as I push this apply seismic load button, the program starts to run the analysis in ETABS. So the reason that it runs the analysis is that it wants to get the attributed or the mass assigned to each joint. So it runs the analysis based on the load, dead loads, live load, and other loads that you have defined in your mass source and on the floor. It will read the mass assigned to each joint, and then distributes the total lateral force based on the tributary mass of each joint. This has now been done for this example, so I can see the loads and I can see the load cases that are automatically generated by the software. So if I go to here, display load assigned joints, I can see here that these are the original load cases defined by the user, and these are the automatic load cases which are defined by AutoDiaphragm. So this shows the earthquake in the X direction and Y direction, X positive, Y positive, X negative, Y negative. And these loads have been assigned. If I, for example, go and right click on one of the joints, I can now see to some reason that has not been applied. I need to see what the reason has been here. Did I run the analysis correctly, or I need to, normally if you see that no load has been assigned, it's because of the mass source. I just check the mass source here. If there is no mass source, then there won't be any load assigned to it. I just make sure that I've got dead loads assigned to this model. And yes, I do have dead loads, so therefore I go back again, I double check this is 1,000, and I go apply seismic loads. I go back here, cases to run. I make sure that these cases will be run, and I go apply seismic loads again. Yeah, I'm just repeating the process because for some reason the loads were not assigned. Typically that happens if there is no mass assigned to a joint. So if you see this this one, it's not an error, it's just something that goes back to the masses that are at each joint. If there is no mass assigned to each joint, there is no load assigned to it. So I'll double check this. So it runs the analysis, it reads the masses, it applies, distributes the loads, the total load between the joints based on the tributary mass. It is still doing the process, and then opens the ETABS log for you, so that you've got the model ready for you to use. Yeah. So now you can see here, if I go to the loads here, I can see the loads that have been applied to each node in the X negative direction, in the X positive direction, in the Y negative, and in the Y positive direction. You might wonder that why this value is 1. This is not actually 1. It is just rounded up or down in ETABS because of the decimals chosen. So that load has been in fact distributed. If you want to better see them, that loads, you can always go to joint and select this option, and you can see these apply forces to each joint. If I, for example, zoom, you can see that this one is 1 and this one is almost half of this, and the reason is that the tributary mass of this joint is less than this. You can see that this joint has taken more load, and that is because of the weight of the column, weight of the beams, and everything has been concentrated on this one. If you also wanted to have same force distributed to this point, then you could actually delete the original beams in the model. You can also simply do that. So I forgot to mention that if you don't want to use your existing structure, I mean the specific beams in your analysis, what you can do, you can simply delete them from your analysis. I'll show you how I can do it here. So I go to the select option and I go select groups here, and automatically two automatic groups have been generated, one for the diagonals, one for the horizontal orthogonal components. If I go select, I can simply go here, view, make selected objects invisible. So I have hidden those components, and now I can go and select these beams, the rest of the beams, and delete them from the model. And I can just repeat this process, but I'm just showing you how you can do it. I don't want to do it at this stage, but I just wanted to show that this groups that have been defined here automatically by Diaphragm are to help you to simplify everything that you want to do. So once the loads are assigned at each node, the next step is simply just to run the analysis. I run the analysis, and then your strut and tie analysis is completed. Once this is completed, I'm just gonna unmute everyone, or allow everyone to unmute themselves. And if there's any questions, I'm happy to answer. And I hope that gave you an overview of Diaphragm. It's the product that it's a brainchild of mine, and it's been worked on it for around 1.5 years for the first development, and since then has been used by several different companies. Obviously, there's not enough time for me to show all the features and how you can actually use it for different project requirements, but it gives you every option that you need for a diaphragm design and analysis. And it's very simple. It saves a lot of time. Eventually, it saves a lot of cost, because also it prevents you from designing very conservative floor diaphragms. So I have just shown you how the loads have been distributed and assigned after the analysis. You can see from here that as we get closer to the shear walls, this tension forces increases, and you can see how the loads for this example in the X direction have been distributed in the floor diaphragm, and then eventually those loads have been taken and gone into our shear walls. So that concludes this very brief presentation here. Some of you may have already purchased the software, and others may be thinking about purchasing it. I would be happy now to take questions if there is any. Otherwise, yeah, I wish you the best, and hopefully I can hear back from you guys